Let me know if you don't have access to it.
Everyone.
Hello. I think recording is already start going.
We don't have access.
Hi, Linda. How are you?
Good, good. I just saw you started the recording. I apologize.
So we're going to wait for another 3 minutes, and then we can start. I think Roman has sent out the Waffle link. If you get a chance to put your name in the Waffle form, sign up for the Waffle using that form. At the end of the session, Roman is going to put together the Waffle later on today. I can see that Roman had pinned the Waffle phone at the top of the chat, so you can look for it. All right, how's everybody doing tonight? Thank you for coming. Thank you for joining us tonight. We're going to start in 1 minute. Hi, David.
Hi.
How's it going?
Good.
All right. Give it a minute, and then we can start. So I'm gonna switch it back to the tracker for 1 minute. So this is a tracker. There's 164 folks signed up for this. If you don't see your name, I'm going to share this link as well. If you don't see your names in the tracker, let us know. We'll add you to that. So today is week 3. And we have 1 batch to complete, and this is machine learning in the enterprise. For those that has completed, you get a check mark on it. And look like there's still a lot of people have not been completing this course. So the machine learning in the enterprise is kind of long. It took a little bit, quite a bit of time to complete it. Okay, so we can get started. Oh yeah, Roman shared a link to the form for the trial.
You are muted somehow. I don't know.
Sorry.
All of the sudden.
Oh, sorry. Somehow I've been muted. Thank you. Anyway, so I was saying that Roman has shared the tracker form. If you notice your name is not on tracker, please fill out the form. And Roman will add your name to the tracker momentarily. I think it's going to take a little bit. It's not going to be happening tonight, I don't believe. So Roman had to go edit some file and then redeploying the app. So, but anyway, I'm gonna go start. I'm gonna display the slide. So this is week 3 again for the professional machine learning engineer certification, road to certifications track. So we're on week 3. And first of all, thanks to a lot of co-hosting chapter, the GDG chapter, Cloud Boston, Capital Region, San Antonio, Ocala, Tampa Bay, Spey Coast, Modesto, Surrey. All right, gonna go to the next slide. So this is basically weekly tracking slide that to tell us where we are. So this week, week 3, we're gonna go over the machine learning in the enterprise. So first of all, I'm going to talk. This is the raffle page that we're going to raffle these items out. Roman has shared the link of the raffle form. So pin at the top of the chat window, and please click that link and fill out the form if you would like to participate in the raffle. Okay. All right. And good luck with that and in the raffle later on. So I mentioned week 3, we're going to be covering machine learning in the enterprise. So this is the batch I actually put in. So I'm completing the batch, and that means you have a check mark on it. So you make sure that you're completing this batch. Maybe before the next session, because you can have week 4 courses that you have to complete. So I think in a couple of 2 sessions previously, we have a look into how machine learning works, and from the data processing to the model training and deployment perspective. We also looked at Google TensorFlow framework, where we can actually train and deploy machine learning model in Python. We also look at another different way of using Vertex AI to train the model. For example, we're using AutoML to train the model. So this week we'll be talking about machine learning workflow. Basically we actually have talked some of the workflow before, but we are covering the workflow in terms of the enterprise perspective. So in the enterprise, there are diverse stakeholders who are software developer and data analysts and data scientists, and each individual had their own set of skills where they might not be familiar with the entire machine learning workflow. So it is important to have a process in place in the enterprise to share and collaborate machine learning knowledge among the stakeholders. In addition, the enterprise needs to invest the infrastructure for developing, testing, and deploying and monitoring machine learning models for their applications. This is translating to building the ML ops. So just like ML ops is very similar to CI/CD. You know, when you're building your own regular, typical, let's say website application, you would probably have a development environment for you to develop your code, and then there's a staging environment you need to set up so that you can actually test it in the staging environment by the QA folks. And then there's a production environment that you would deploy your application to the production environment and monitor the health of the application. So this is very, for machine learning workflow, this is very similar. That we have the enterprise need to create that type of infrastructure to support their machine learning application development. And in terms of in this slide, we are basically talking about expanding the machine learning workflow a little bit and then focus on the detail in terms of the environment, experimentation and prototyping area. So on the left, we have the data processing, feature data pre-processing, including the data engineering and feature engineering, and then on the data side. And then we are performing and in the previous week, we have covered feature engineering, where we actually explore the data to define feature column and labels. We also explore the feature store in Google Cloud. So data scientists develop model on an experimental platform, iteratively going through the process of defining the problem and doing data selection and data explorations, and then do the feature engineering, and then do the model prototyping and model validation, and go back in the loop until they are finally comfortable with what they're developing. At the end, once you have the model trained, and then that's stored in the model registry, and then after that, you can actually deploy the model to the for prediction. And then if the model needs to be repeatedly trained in the future, an automated training pipeline is also developed. And we refer to this task as training operationalization, which is on the lower right-hand corner here. And after we have the model developed, and then we can move the model to the deployment phase. And when the model is deployed to the target environment using either Google service, Google application service, and then we can set up an endpoint and for online predictions. As you can see, the model deployment is constructing, meaning you have this CI/CD pipeline I mentioned earlier. We do the build, and then we do the test, and then after we're satisfied with the test, and then we deploy to production. And in the production environment, we have our online experimentation here, and then you have the metadata and all that. We're retrieving the metadata and artifact repository. So, I mean, all of these, the model registry is part of Google Cloud, part of the Vertex AI platform. Excuse me. So when the model is served up for predictions, and then there's various ways that we can actually using the model serving to do the one is for online inferencing. That means in real time using as a REST API, we can do the prediction using a REST API. The streaming interference is near real time, such as event processing pipeline that they're going to use for streaming. And batch inferencing is offline. Usually you have to integrate with your ETL, which is the extract, transform, and load processing pipeline. The embedded inferencing is doing on the embedded system. So embedded system could be an edge device in the cloud to do the inferencing. So Google Cloud ML tool, so is the Vertex AI is one of the Google Cloud environment where you can actually develop your entire machine learning workflow within this environment. So this is a tool is for every step in machine learning workflow across different model types. You can actually develop different model. And then we have reviewed the typical machine learning workflow I mentioned previously. And after you have defined the problem, and then you can go off and do your data analysis. So then you're defining your data ingestion state, analyze the data, and then do the data transformations. So that's the data preparation phase. And then after you complete the data preparation phase, you can actually start training the model, either using AutoML or a custom model training. I'll talk about a little bit about in a couple of slides later on to talk about what is a custom model training. And once we got the model, we can evaluate the model and optimize it, and even understanding signal behind the prediction by using the explainable AI. Expandable AI lets you dive deeper and understand which factors are playing a key role in defining what the model is predicting. And then afterwards, we're satisfied with the evaluation step, and then we can actually deploy the model. So I mentioned earlier, deploying the model we're using physical resource in Google Cloud or another cloud if you do it in another cloud. Using the scalable hardware to scale the model for low latency in Google Cloud to deploy the model to the endpoint for use with online prediction. And after it has been deployed, you can actually using a command line or the Google Cloud Console or an SDK, which is a REST API, to do the prediction. Vertex AI provides the tools to support the machine learning workflow from data management all the way to prediction. So as you can see, that there's a lot of tools within Vertex AI, and we only cover a few of them here. So data in the enterprise. So data in the enterprise. So regarding how the data management aspect, what the data management aspect in the enterprise. In the course, we're only focused on the feature store. The actual feature store has been discussed in the previous session, but I'm going to touch a little bit on it a little bit here. So in the feature engineering course, and then we are talking about what the feature is and what is the feature, what is its use in machine learning. So a feature is a measurable and recordable property of an entity. For example, let's see. For example, age of a person. This is one of the features. So here we're describing how to use the feature store so that we can actually use this to collaborate with various different stakeholders in the enterprise. So I mentioned earlier the XYZ team had added engineering feature engineering skill under their belt. Now they have multiple teams now. So each team is developing the same feature, and this is leading to a redundant work for each time when they need to add new feature to the ML model. So how do we solve this problem? So they're also depending on the ops team to deploy the feature. So they need a way to manage the life cycle of the feature from training to deployment and serving. So the developer needs to add ML prediction to the app by the online prediction endpoint. So the feature still allow them to do sharing the feature between the training and predictions. Here we are talking about the key challenges regarding the ML feature that come up very often. Mentioned about collaborations. One of the challenges is hard to share and reuse the feature. It's hard to serve in production reliably with low latency, and then there could be inadvertently skew the feature value between training and serving, so that's causing problem, meaning causing unreliable prediction at the end for the prediction. So the team is facing those challenges. They're in the enterprise. We are creating a feature store and user feature store, to allow us to share the feature value within different teams, so they don't have to duplicate development of the features. So in this slide, we're talking about some of the way of managing the features, using the managed feature store. So now we can use feature stores to share and reuse the ML feature across use cases. So Vertex AI feature store, Vertex AI feature store is a managed solution when they manage and scale the underlying infrastructure for the team, such as storage and computing resources. So you don't have to worry about the underlying computing resources. The Google Cloud will manage all of the resources for you. So the data scientists can focus on the feature computation logic instead of worrying about how to deploy them. A common problem in machine learning is that the data that you train with may be skewed or different from the data that is served in production. So the feature store alleviates the training skew because it allows the team to compute the feature value once, and we use both in training and in serving for prediction. The team can monitor for drift and other quality issues. The ML machine learning stakeholder or team can use feature store API to manage new feature ingest into the machine learning pipeline. So there's a various way we can solve the problem of the challenge that we talked about earlier. Let's see. I don't know if you can see this, but this is this is highlighted in the feature store. The feature store in Vertex AI, where we're defining the feature of the entity budgets. So this entity had 1, 2, 3, 5 features. The budget ID is probably not used as a feature, but that's how the structure for the data set. And then I can see, I think it's newspaper budgets, and then the radio budgets, and sales total, and then the TV budgets. And basically, this is how it's being stored. There's a way that it is stored in specified region, US Central 1, and there's a way that we can use this to share between the model training and model serving with different stakeholders. So different stakeholders have access to Vertex AI, and they can see all the different features in the feature store. So as you can see in this slide, Vertex AI feature store uses a combination of a store system and component under the hood. As mentioned previously, the feature store provides SDK or API to manage the features. So you can see in the picture, for feature management API, it's talking, you can use that to manipulate the registry. You can use the batch ingestion API to send it to the online store, the online feature store, or offline feature store. You also do the same thing using a stream ingestion API to stream the data into the online feature store or offline feature store. From the registry, you can use the feature discovery API to discover different features. And then the online serving API, you can query the online feature store for the feature that you like to use. And then the batch serving API, the same thing, using the API to get to the online feature store. And once you get a feature, you can send it to the online prediction or model training. There's a number of tools that can be used for managing data, machine learning data in Google Cloud, especially in Google Cloud Vertex AI. So in most enterprise today, they are dealing with a large and growing number of data sets. So as the data set get bigger, is more complex, and some of the data stakeholder like consumer, producer, and administrator within the enterprise, they face a number of challenges in searching for insightful data, understanding the data, and making the data useful. So if you have data scattered within Google Cloud environment in various places, this make it difficult to find the data to look for the insightful in the data. So data catalog can catalog the native metadata of the data assets from the Google Cloud system sources. So data catalog also allow team to use their data catalog API to create a managed entry for custom data source type. And Dataplex is another tool. So Dataplex is the intelligent data fabric that enable enterprise to centrally manage, monitor, and govern the data across the data lake and data warehouse and data mart with consistent control, provide access to trusted data, empowering analytics at scale. So data warehouse where you would create it getting all the data from the operational database into the data warehouse where you can do analytics, and that's the same as data lake. I believe it's also the same as data mart. I'm not familiar with data mart. But anyway, and with Dataplex, you can achieve the freedom of choice to store the data where you want for the right price, performance, and choose the best analytics tool for the job, including the Google Cloud and open source analytic technologies such as the Apache Spark and Presto. You can enforce consistent control across the data to ensure unified security and governance. You can take advantage of the built-in data intelligence using Google best-in-class AI ML capability to automate much of the manual toil around data management and get access to high-quality data and organize and manage your data in a way that makes sense for your business without data movement or duplications. So Analytic Hub is also another Google managed service. Allow you to efficiently and securely exchange data analytic across assets across organization to address challenge of data reliability and cost. You can create and access the created library of internal and external assets, including unique data set like Google Trend. It has a easy interface for publish to discover and subscribe valuable data set that you can combine with your own data to derive unique insight. There's a number of roles in Analytic Hub and data publisher, exchange administrator, and data subscriber. And there's a couple of components within the Analytic Hub. We have a publisher project, a subscriber project, and exchange. So I believe there's a lab that we actually went to in the course and allow you to experiment some of this feature. So the data processing options, so in terms of data management, we have a number of tools that we can use to process the data. So BigQuery is suited for tabular data and data processing and transformation step. When you're working with machine learning, okay, I have a question here. Ed asking, should I even start machine learning enterprise? Yes, I guess you're following to the weekly session, and you should start going to it. I mean, some of the material you may be familiar if you have taken the previously. Oh, you worry about the deprecation. I'm not sure I haven't seen it. I'm not aware about the deprecation. Well, yeah, I'm going to continue. So, and then data flow is a good for converting the unstructured data into binary data format like TF record. So as you know, TF record is TensorFlow data format, and which can be improved performance of data ingestion during training. Is the binary format. If you are working with Hadoop and Spark to perform ETL, Dataproc is recommended. And this is especially designed for those who want to leverage the experience with Hadoop on-premise to create a cloud-based solutions. If you're using TensorFlows for your modeling development, TensorFlow Extend or TFX is recommended for preparing the data for training. TensorFlow transformation is the TensorFlow's component that enable defining and executing pre-processing function to transform the data. And data prep is used when you have business data that is originated from various sources. So data prep provide tool to correct and clean your data, and tool also changing the format of the data to conform the correct desired state. So this is like dealing with the data processing at the early stage of the machine learning workflow. And finally, it provides validation to ensure that the data conform to the required data set for analysis. So some of these are very important tools that you might need to use to make sure your input data to the model training is correct. So now we come to the machine learning custom training. Before I talk about custom training, there's few things about the training parameter. So some of these they call hyperparameter. So the learning rate and batch size. So the learning rates control the size of the step in the wait state. If the step is too small, the training would take a long time. If it's too large, the training become bounced around. So that your prediction value outcome will be not consistent. I think one of the things that you may have to look at is that your gradient descent. Look at the gradient descent is actually smooth or actually bouncing around. And versus the batch size is actually on the opposite direction. If the batch size is too small, the training would be bounced around. If it's too large, it will take a long time. So there's a predefined, they actually recommended setting for the initial setting for the training rate and batch size. So as you can see, with the larger batch size, it's kind of require a smaller learning rate. You can see this graph, as you, so on here, the learning rates on the right-hand side, the larger, and it goes smaller to the left. So we're just showing the relative to the training accuracy, depending on the batch size and training rate. So the model performance is very sensitive to learning rate and batch size. The larger batch size requires smaller learning rate. However, deep learning is still very complex, and there is no hard and fast rule for picking a learning rate and batch size. That means you may have to run your model training multiple times to get the best result. So training a complex network with large amount of data can often take a long time. So how do you actually taking care of, how do you get improvement? So we're talking about scaling now. So scaling with distributed training, you can actually use one machine with a single CPU and single device or multiple device. I mean, these device, I think referring to number of CPU, number of GPU, and sometimes you may have to use multiple machine with possible multiple device each connected over a network. Eventually, with various approaches, you can actually scale up to hundreds of devices, and that's actually they talk about some of this aspect in the course, where later on you might have to scale by have multiple nodes to actually alleviate the trainings, because if the training takes using one single device take a month, you cannot afford, the enterprise cannot afford to have the training done in a month. And that's too long for training. Sometimes you might want to have the training to perform within a couple of days. I mean, you have to increase your capacity to get the performance that you want. And then, see, this picture is just showing that you scale up as you increase the performance. So you have 1 GPU, 2 GPU, 4 GPU, and 8 GPU relative to the performance to the left. Vertex AI mentioned earlier that provide a couple of different ways of do the model training. So AutoML is suited for app developer, data admin, analyst, and ML data scientist and data engineer who, because AutoML does not require you to do a lot of coding. There's actually no code. And basically, it's all using the console and then using the GUI to create a training. And BigQuery ML. So BigQuery ML require you to understanding some of the SQL syntax. You might have to be familiar with the SQL syntax. If you don't, then AutoML may be best suited for you. But the BigQuery ML is designed for targeted for the DB admin, the machine learning and data scientist, and data engineer. And then the custom. So the custom model training is that when you have a problem that requires you to to do the training that requires special a number of hidden layers, some of the tuning parameter. This is more complex. Then you have to write your own code using TensorFlow or other machine learning packages that allow you to do adding the hidden layer to the network, and then changing the hyperparameter to tune your model. Here is a slide to allow it to figure out in different use cases and which machine learning training tool that we should be using, either AutoML or custom training. So the data science expertise needed doesn't need, so AutoML doesn't need any data science expertise. So this is good for somebody just want to do simple machine learning model. So they can just ask AutoML to do for them. And also, of course, you can, with the custom training, you can actually do the simple model as well. And then programming skill ability needed. So like I said, AutoML doesn't need any programming. It's no code. And custom training, yes, you need to be familiar with some programming. So you can do the custom training on the model. As also time to train the model. If you the model training doesn't take a lot of time, so AutoML, we can use this. And then for higher training time, then we can use the custom training. Limits on machine learning objective. Yes, so AutoML you can do that, and you can AutoML provide some of the predefined objective for you. In custom training, unfortunately, they said no, you cannot do this. And can manually optimize the model performance with hyperparameter tuning. So we discussed hyperparameter tuning require you to use kind of like custom training. So AutoML, no, it doesn't do automated hyperparameter tuning. But you can modify the value used. In custom training, you can do all of that yourself, or using a tool for it. So, Vertex AI provide custom training facility to allow you to do your custom training. So there's a benefit of using the Vertex AI custom training service. You can do local training first. Instead of training your model directly within your notebook, you can actually send it from your notebook. You can actually call, I think it's called a platform, AI platform API. So you can submit a job to Vertex AI to perform the training for you. And then you can create a modular architecture. So that means you put in your code, your custom training code into a container so that it can be portable and can be reused somewhere else. So this is some of the exercises. We actually create a Docker file and a Docker container. So that is a modular architecture. So all the code is within the Docker container for custom training. And the advantage of that, having the Vertex AI doing custom training for you, is that because they're including the logging, the cloud logging. So each time the job is tracked with input and output, and then the container image used, and then they spit out error if there's some problem with it. I actually ran into the problem where I was doing one of the lab, I forgot to make some changes in one of the source file, and then I was scratching my head as what's going on. So, and then I look at the log, and then the log is that I didn't specify my project ID or something like that in the file. Distributed training, you can train model across multiple nodes in parallel. So I mentioned earlier, this is good for distributed training and also for like increase your model training time. Decrease the model training time so that model is training faster with multiple machines. Vertex AI Vizier. This is the tool for hyperparameter tuning. So this is a black box optimization service that helps tune hyperparameter in complex machine learning model. When you have many different hyperparameter, it can be difficult and time consuming to tune these parameters manually. Vertex AI Vizier optimize the model's output by tuning hyperparameter for you. So it's a service that operated in Google Cloud and allow you to define your study plan. So you actually there's one lab specifying for it. You have to specify the study plan, and once you create a study plan and then create a metric where how you want your hyperparameter tuned, and then after you're done with that, you submit a job into Google Vertex AI, and then it's actually automatically do the tuning for you, and it provides you some of the output, and you can review, and you can actually redo it again if you needed to. So, so this is actually showing some of the hyperparameter. We're talking about the learning rate, epochs, and hidden units. This is actually hidden layer. in the multi-layer neural network, then you can have multiple hidden layer. This is the minute batch size, also the batch size I mentioned earlier. So although machine learning model automatically learn from the data, they still require user-defined tuning the knob to guide the learning process. So this knob, they're known as hyperparameter control. For example, the trade-off between training accuracy and generalizability. So I already mentioned these are some of the hyperparameters listed in this slide here. So the Vertex Vizier has a couple of different ways that you can specify in the study plan. You can ask for grid search, random search, and Bayesian optimization. Because the Vizier is a black box optimization service, so the grid search is a traditional technique for hyperparameter tuning. In the grid search method, and we can set up a grid of specific model hyperparameter and then test a problem statement model on every combination of value. For random search, and you can set up a grid specific model hyperparameter value also. But here we select a combination hyperparameter value randomly. The random search tuning technique is faster than the grid search, but the grid search is more effective than the random search because the random search misses a few combinations. You can see it. You can see the in the picture itself. See all the grid search cover all the dots, and then the random layout scatter scattered around the grid. And then the last one is Bayesian optimizations. So this approach typically requires fewer iterations to get the optimal set of hyperparameter value, most notably because it is regarded those areas of the parameter space that is believed won't produce useful result. This in turn limits the number of times the model needs to be trained for validations, because only those settings that are expected to generate a higher validation score are passed to for validation. For evaluations. Okay, I'm checking the time. I think that should be enough time. Okay, now we're going to go over the prediction model monitoring using Vertex AI. Prediction and model monitoring will allow you to request either batch or online prediction. Either go to the BigQuery table or CSV file or from a pre-built or custom container. And to monitor training serving skill. So some data may be just skews, so your prediction is not going to be as satisfactory. So with the model monitoring put in place, it allow you to assess what's happening in your model. So I'm going to go to the next. So in batch prediction, let you make many prediction requests as one, because it is, is an offline batch request, and it's asynchronous. This means that the model will wait until the processing of all the prediction requests before actually returning and do the CVS file or BigQuery table with prediction. So the online prediction is useful if the model is part of the an application and part of your system, depending on the quick prediction turnaround. So this is monitoring. So we want the Vertex AI model monitoring tool to help us to detect the drip in data quality. And I think we studied the data quality in previous session. So this monitoring allows you detecting those data quality when it changed. And this also identifies skew in training versus serving data. And we can monitor feature attribution. So feature attributions are a way to measure how much each feature in the model contributes to the predictions. And use the UI to visualize the monitoring metric. So in the enterprise, most machining workflow, I believe typical, they wanted to have it built within the pipeline. So Vertex AI pipeline and let you orchestrate your machine learning workflow in a serverless manner. Meaning that it's a different they create a different component to very part of your workflow. Machine learning pipeline, the portable and scalable machine learning workflow that are based on container and Google Cloud services. So how do you build a pipeline? So you have to. So before the Vertex AI pipeline, you can actually do it in AutoML and then using GUI to do it. But with with the pipeline, you have to describe your workflow as a pipeline, meaning you have to do it in code. You can either do it in the TFX, which is the TensorFlow extended, or you can do it in something called Kubeflow. So Kubeflow, I'm going to describe it next. So the pipeline, because the pipelines are portable and scalable, so it allow you to manage each component independently. So Kubeflow is an open source Kubernetes native platform for developing, orchestrating, deploying, and running scalable and portable machine learning workflow. It helps support reproducibility and collaboration in machine learning workflow lifecycle, allow you to manage end-to-end orchestration of machine learning pipeline to run your workflow in multiple or hyper environment. So this is one example of using KFP, I believe that's a Kubeflow package. And you specify the project ID and region, the pipeline route, all this. There's actually more to this since I didn't include some of the other detailed coding in here. I'll let you, when you're actually reviewing the course, let you pay attention for some of those. Best practice for machine learning development on Vertex AIs. So there is the last course section of the course, we're talking about some of the best practice in the machine learning workflow. So model deployment and serving. So for model deployment and serving, refer to the putting a model. I mentioned putting model into production. So the output of the training job of model file is stored on Google Cloud Storage, where you can actually upload to Vertex AI so that the file can be used for prediction serving. Best practice is specify the number and type of machine you need, and then plan the input to the model, and then turn on automatic scaling and turn on, yeah. So that means you can actually scale for do a scaling for your training and prediction. Define what is good and bad performance. For best practice for model monitoring, and this is just a picture I got it from the slide. Basically, we want to monitor, we want to monitor the skew, the data drift, and we want to set up a loss threshold so we can actually receive the alert, through email or something like that, so we can be aware of what's happening when the model is running in production. There's also we can monitor the input into the model, track the model input to see if there's any outlier. So monitoring only, I think it works for structured data like numerical and categorical features, but it's not for unstructured data like images. And best practice for the pipeline. So for the pipeline, mentioned how you have to automate, monitor, and govern your machine learning system by orchestrating your ML workflow in a serverless manner. Pipeline automate the training and deployment of models. So when you're running a pipeline using Vertex AI pipeline, the artifacts and metadata of the pipeline runs and stored in Vertex AI, Vertex ML metadata. So as best practice, so you want to assess the perfection. So why did a certain pipeline run produce a especially accurate model? So you also want to compare the different pipeline runs so that what hyperparameter was used to train the model too, right? So when I compare the different hyperparameter value. So why is one is different, better than the other? So you can also implement the system governance, and depending on the step that in your pipeline, you may able to use vertical ML metadata to answer system governance question. For example, you could use metadata to determine which version of the model was used was in production at a given time. So this is the last one for artifacts organization. As a software developer, we always managing the output artifacts that we produce. So this is no different than machine learning workflow. So we're going to use a Git repo for pipeline definition and training code. Machine learning in the enterprise, they actually recommend this. Use the artifacts registry to store, manage, and secure your Docker container image without making them publicly visible. We do the same thing for our code. We use the artifact registry to store code container in artifact registry when we actually deploy our application to Google Cloud, and we're just going to reference that. And then, because Artifactory allow you to have versioning control in the registry, you can know which version of the application actually deployed into Google Cloud. I think that's the last slide. So I just want to say that I only cover probably maybe 1/3 or 2/3 of the entire course. There's so much material in this course. As I mentioned earlier, this course is kind of lengthy, a little long. It took me a while to complete it. I think that's it. So are there any questions?
Side of this session, but I just wanted to at least acknowledge Kevin's time. So please let's give him a round of virtual applause to Kevin. Thank you, Kevin, for leading session 3 tonight. So thank you so much for your time. So let's give folks a few seconds.
You're very welcome. I'm glad to be able to do this.
Awesome. Thank you. So please, I'll drop the raffle form one more time in the chat. Please, I'll give you like about 30 seconds so that we can now do the raffle.
I'm going to stop sharing so you can take over to share your screen.
Correct. So let me share my screen. I just want to, again, thank everybody for joining tonight. And while I'm doing this, you guys can start preparing. Remember to do our usual ritual of the night, which is taking a picture among everybody. So I know some of you are like, man, I have a very bad hair day today. But hey, remember, this is... Oh, I see Linquid. Hey, what's up? How you doing? She's already doing the side. That's awesome. Very good. Very good. You're almost there. Let's do the raffle first and then do that. But yes, appreciate it. Thank you. Thank you so much, everybody. So yes, remember today's raffle is, remember, if you get picked, you will let me actually show it one more time. So if you get picked, in today's raffle, you will pick one of these 4 items from the swag store, from the Google merchandise store. If you're in the US or Canada, you should be all set. If you're not in the US, then we will compensate you with a gift card. So please let us know. And it doesn't matter. You could be a repeat. If you already got it last week and you got it again, I mean, that's what luck is for. So, but anyway, yes, please put your name on the raffle form. Let's put it. I'll give you. See, I'll leave you. I'm going to give you 30 seconds for that. Preeti, are there additional resources like practice quiz? Yes, every office hours For example, next week's Wednesday, we will be doing practice exam questions, and I have a surprise for all of you. I have found, don't ask me where, but I found a couple of, exam legit questions that we can practice mixed up with the questions from the Cloud Skills Boost to kind of give it that value, and so that you actually practice, real, very close to real, legit exam questions from the exam. So again, that is the uniqueness and the exclusivity of our office hours every other Wednesday. So I hope you guys can join next Wednesday. We'll do exam questions prep. And please join. We're going to have amazing questions in there to review. Thank you, Preeti, for your question. And thank you again for bringing your community from Canada. GDG Surrey in the house. So who else? I mean, you want to say something, Preeti? I mean, you're part of the co-hosting chapters. You want to say something to the...
Oh, no, I'm good. I was just saying hello to everyone. I see familiar names, and it seems that I am actually late joining these sessions. So yeah, I would love to be part of other sessions and learn with everybody and see if I can clear the exam. Yeah.
Thank you so much again. So yes, so I'll give you. I
Yeah,
think we should
same
be
here. I hope I clear the exam too.
Definitely. Awesome. Okay, so let's proceed with the names. I will pull all the names. Let me see if I have them here. No, that's just something else. Let me grab.
Actually, this will be my 8th certification exam this year. I took 7. Luckily,
Oh yeah, I
passed
said
all of them.
congrats, Linda. I said earlier, I said congrats for taking the AWS certification. Talk about going to the competition.
Yeah, this year I got Oracle, Azure, AWS, and Google. I got all of them.
Wow, you're allowed to go off the competition, huh?
Yeah,
Yes.
Accenture actually works with all of them, so it doesn't really matter,
It's true. Yeah, a lot of the knowledge crosses over. So yeah, so let's proceed now with the raffle. Again, one more time, the raffle will be one of these items if you get picked. So good luck to everybody, and I'm gonna
good luck to everybody.
Who's gonna be tonight's winner? And tonight's winner is Francois. How you doing, buddy? Are you here? We need to make sure that you are here. Hey, there you are. Perfect. Awesome. So congrats to you. We will be shipping one of the items that you pick from week 3. So again, we're going to reach out to you offline. We're going to send you an email, and then you pick one of these items, and then we'll ship it to you. Okay. Awesome. Thank you. So I'm going to stop sharing. And if we all don't mind and opening up our cameras, let me see. I think I am good to share. Oh, okay. Wait, I don't have my camera. So why don't you all go? And let me also, Linda, I think you're the designated, picture photographer. So let's all do our customary GDG signal while Linda takes a couple of screenshots. I see
all of you has to be a little bit patient with me because I have 4 pages here with people. I don't know in which one you are, so
no problem. But I see Lisa.
Just smile. Everyone, just smile. Slowly, I go to the next page. One second. Smile, everyone, smile. I took the first 2, now the 3rd page.
Yeah, keep smiling because sometimes people land in different pages. So.
Yeah, so I don't really know. The first and the second has people with the camera on. I see the 3rd that doesn't have. Let's see the 4th page. Oh, the 4th disappeared in the meantime. Some people dropped from the call. It's only 3. I took all of them.
Okay, awesome. Again, thank you very much, everybody. Thank you, Linda, again for taking the picture. See you next Wednesday for the office hours, answering questions, prepping for the exam with some legit questions. So please tune in. We're going to have a lot of fun. Have a great night. Thank you so much for joining.
Very
Thank
nice. See you next week.
you.
Thank you.
Everybody, have a great night.
Thank you, everyone. Have a good night.